Okay, here we go. I know you guys can't tell, but this is actually the fifth time I'm trying this. I just lost my video doing touch. I just can't do it anymore. Why do you need to know that? I have no idea. So let's, for the sixth time, try to see if I can actually make this one a decent one. All right, here we go. So, school trip. Every 15 students needs an adult. So on a recent trip, 338 students went to the movie. So let's find out how many adults went along with them. So here you have your 338 students. And you know we need to make groups of 15 because every 15 students requires an adult. So let's see how many adults ended up going with these kids. So 15 does not go into 3. If you want to put that, just as a placeholder so we don't confuse. So 15 goes into 33, yes it does, and we put that 2 on top of the 15. That gives you 30. Subtract 3, 8 comes down, 15 goes to 38 twice as well. And that's 30, and we have 8 students left over. So out of 338 students, and I'll make this, you were able to make 1, 2, 3, 4, 5. I'm not going to count, but I'll do. So there were all these students divided into groups. 22 groups. Every group had one adult chaperoning them. So one adult in each of these groups. So far we know that there's 22 groups, so 22 group means 22 adults. Okay, so what about these 8 students over here? Were they left behind at school? No, they still came, and guess what? They also needed an adult. Okay, even though there weren't 15 of them, but they also needed. So there was one adult taking care of these 8 students. Okay, so the answer is a little bit tricky here. Okay, so if you put your answer as 22, because the question says how many adults went as well. Well, 22 adults went for sure because there were 22 groups of 15 here, one adult for each group. But these kids here, these 8, also needed a chaperone, also needed an adult. So for this 8 kids, school also needed to send an adult with them. So 22 for sure, take care of these guys, of these 15 groups, 22 groups of 15. And then one adult had only 8 students to look after. Okay, so the answer to the question, 23 adults went to the movies. Okay, please, I beg you, show all your work, and if you need to write a sentence, write it out. Okay. 2. A medium-sized truck can hold 85 small moving boxes. Okay. And Sam's Toy Company finished packing 1,034. How many trips? How many? I forgot the word many there. How many trips will it take the truck to move all the boxes to the store? So here's, I guess, your factory where you make the toys. So the factory has 1,034 boxes full of toys for children. And then there's a truck. Can I make a truck? Can I draw a truck? Okay, so there's your truck. Okay, 2 tires. And this truck has to go here to the store. Okay, carrying all these boxes, but the truck can only take 85 boxes at a time. So how many times will this truck have to go back and forth from the factory to the store? So 1,034 divided by 85. 85 goes into 1, no. Goes into 10, no again. Goes into 3, 1 time. 85. 5. Okay, there we go. Subtract. Let's see all that magic thing. This becomes a 10, which becomes a 9. 13 minus 5 is 8. 9 minus 8 is 1. And we bring it down to 4. Can 85 go into an 84? It certainly can, about 2 times. And that means it's 170. And 4 minus 0 is 4. 8 minus 7 is 1. Okay, so careful here. The truck will make 12 trips. First trip is going to take 85 boxes. 85 boxes. Second trip, 85 boxes. And he's going to take 4, 5, 6, 7, 8, 9 trips, 10 trips, 11 trips, 12 trips. 12 trips he will go, but will he have taken all the boxes? No, after 12 trips, guess how many still are left over? 14 boxes are still left over at the factory. Does he need to take one more trip? Yes, it does. So on that last trip, he's going to take 14 boxes because all these boxes have to go to the store. Okay, so for sure, 12 trips where his maximum load will be at its maximum with 85 boxes in each trip, and then the last trip he will take 14 boxes. So how many trips does he take? Not 12, careful, 12 for sure, and then on the last trip, the 13th trip, is going to take 14 boxes. So the answer to this question, it will take the little truck, 13 trips. Oops, is that trips? Does that look like trips? Well, it is trips. 13 trips, okay, to move all 1,034 boxes. Okay, please be careful. Read the question. Okay, if you leave it as 12, it's definitely not correct. Okay. Next one, find the prime factorization of 1080. Okay, simple enough. We want to break this so that we write this as a product of only prime numbers. So let's find all the prime numbers that multiplied give you 1080. So let's break this into, let's see. You definitely can use 2. I would go this way. Okay, if you use 2, you did 5 and 540. That's fine. I like to do this way. Okay. 10 becomes 2 and 5. Prime, so circle it so you know not worry about them. 108 becomes 2 and 54. 54 becomes 2 and 27, okay? 27 becomes 3 and 9. 3 circle, and 9 becomes 3 and 3. So, circle, you know you're done. Now, let's rewrite this nicely. So 2 is, how many 2s do we have? 1, 2, 3. So it's 2 times 2 times 2. And how many 3s do we have? 3 3s. 1, 2, 3, and we have a 5. Okay? So, or better yet, in exponential form, 2 to the third power times 3 to the third power times 5. Okay? Why am I having problems? 5. Okay, there we go. That's your the prime factorization of 1080 is 2 to the third times 3 to the third times 5. Okay? Find the prime factorization of 288. Ugh. 2. I like 2. You don't have to think. It's just half of that. 2 and 144. Ooh, nice. So 144, you can do 2 and 72, or why not do 12 and 12? Everybody knows, right? It's a perfect square. 12. Oops. No circle. Back. Okay, so 12 becomes 2 and 6, and 6 becomes 2 and 3. And we can mirror that again on the right side, so it becomes 2 and 6 again. Circle, 2 and 3. Okay, careful here. Okay, you don't forget a 2 or 3. So there's 1, 2, 3, 4, 2. So 1, 2, 3, 4, 2 times 2 times 2 times 2, and we have 1, 2. Oops, look at that. There's one more 2. I forgot. Times 5, and then 1, 2, 3, and 3, or 2 to the 5th times 3 to the 2nd. 2 to the 5th times 3 to the 2nd. Okay. Prime factorization should be very, very easy. Please do not lose a point on that. Chocolate bars are sold in packages of 9. So let me write this. Chocolate comes in a bag, and in the bag there's 9 of them. And granola comes in 14. What's the least amount? Least. Ooh, that should give you a hint. LCM of each that can be bought so that there's the same amount. So, 2 ways you can do this. You can list all the multiples, or you can do the ladder method. If you do the, let's do the ladder method. The ladder method, 9, 14. Is there a number that goes to 9, 14? No, 2 doesn't work. Works for 14, but not in 9. 3 here, but not in here, blah, blah. So it doesn't work. There's nothing. So when there's nothing, remember, it's just these 2. And that becomes 9 times 14, which equals 36. 9, final answer 126. So 126 is the least amount of number of chocolates now, and least amount of granola bars that you need to buy. What do you call? So that they have an even number. Now, if you list them, if you buy 2 packages, 18. If you buy 3 packages, 36, and so forth. This will be 45. If you're listing the multiples, 14, 28. After 28 is 42, I think. Then 42 plus 14, 56. and it keeps going, okay, the multiples until you reach 126, and so does it go here. Now, actually, I should have done it. Well, now, does this mean that you're buying 126 bags of chocolates that have 9 chocolates in each? No, it doesn't. It means that you're going to buy 1 bag, 2 bags, 3, 4. Actually, I should have done it, but 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 bags would you need. And here, you're going to need 1, 2, 3, 4, 5, 6, 7, 8, 9. So, it didn't ask. But if it did ask how many bags of each, you would have bought 14 bags of chocolate and 9 bags of granola for a total of 126 individual pieces of chocolate and 126 individual pieces of granola. Okay. ABC YXZ radio. So they play a commercial, ABC, every 24 minutes. And XYZ plays once every 18 minutes. So we want to know when will these two stations play commercial at the same time. Okay, so what time is it now? 4:20 p.m. Alright, so I would definitely look at LCM. Okay, how do I know it's an LCM problem? Well, in this particular case, it's because you have two things that are repeating over and over and over again that we want to see where they're going to meet up in the future. So if that's the case, it's definitely an LCM problem. 24 and 18. Let's not pick 2. Let's go higher. 3, 4. Let's pick 3. So 3 goes in 24 8 times. 3 goes in 18, I don't know, 6. Ooh, we end up going back to 2. So I should have picked a higher than 3. So instead of 3, I should have thought it was actually 6. So anyways, can't use 3 anymore, but I can use 2. I can go back down 1 and use 2. 2 goes into 8, 4. 2 goes into 6, 3. Nothing goes into 4 and 3, so I am done. So the GCF is a product of these two numbers. Wait, I'm not doing GCF, sorry. I'm doing LCM. So the LCM is a product of all these numbers, the 2 at the bottom and the 2 at the side. And that gives you, let's see, 3, I'm sorry, it's 2 times 3 times 3 times 5. Okay, so the LCM is a product of all those four numbers. 2 and 3 is 6, 6 and 3 is 18, and 18 and 4 is 72. What's the unit? Minutes. So in 72 minutes, after 4:20, both stations will play a commercial at the same time. Now, what does that translate to? 72 minutes is 1 hour, because 60 minutes is 1 hour, and then you have 12 left over, so an hour and 12 minutes. So to be more precise, if it's 4:20 p.m. right now, an hour after is 5:20 plus 12 minutes, it will get you at 5:32. So exactly at 5:32, if you have 2 radios in your hand and you turn one to ABC and the other one to XYZ, they will be playing a commercial. 7. Caitlin and Lydia each. Okay, so Caitlin, we'll call her K, and L for Lydia. Caitlin picked 42 flowers, and Lydia picked 56 flowers. We don't know which type, so we'll just call them K and L. They're going to divide each group of flowers evenly among the vases. What's the greatest number of vases that they can fill? So we're going to put these flowers into vases. Evenly though, same number in each. Same number of Caitlin flowers and same number of Lydia flowers in each of the vases. This is GCF. The very greatest there, should have given you a hint. Ladder, because it's definitely the easier way to go. 2, 21, 28. And we can use 7, which is 3 and 4. GCF is a product of these two. Okay, so GCF is 2 times 14, which is, no, 2 times 7, sorry, which is 14. I'm going to end up having 14 vases. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And each of the vases, you're going to put 3 of Lydia's in each of the vases. Okay. Okay. And 3 of Caitlin's flowers in each vase, and 4 of Lydia's flowers in each vase. Okay, so all the flowers are distributed evenly, and every vase has the same amount of flowers. Okay, that's what these two numbers in this particular question mean. Okay, you'll see later on how it can mean something else. 8. Sophia's making bead necklaces. She has 144 greens and 86 blue beads. How many necklaces can she make? Okay, these are two big numbers. Big numbers is nice. Now, greatest number of identical necklaces. So each necklace is going to have the same number of each color. So the necklace is going to have green and blue. Another necklace is going to have green and blue. And the necklace is going to have green and blue. So the necklace has both green and blue beads. Same amount. 144, that represents the blue. I'm sorry, the green. 86 represents the blue. 2 works, yes. 72, 82 goes to 86, 43. Wow, 43. What a weird number to pick. All right, so 2 goes to 72, but it's not goes to 43. Nothing else will work. So greatest number of necklaces. Look at that. It's just 2. What an easy problem. Somebody made a mistake, meaning me. Okay, so anyways, 1 necklace, second necklace. So in this necklace, you're going to have 72 green beads. 1, 2, 3, 4, 5. All right, I'm not going to draw them out. And 43 blue. 1, 2, 3, 4, whatever, blue. So I'll put 43 here and 72. And the second necklace will be identical. A bunch of green beads, 72 to be precise, and blah, 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 a bunch of blue, 43. So there are your 2 necklaces, same number of beads, and mixed up, obviously, green and blue in each necklace. Pretty easy question. 9. Oh, okay, so this one you have to pay attention to. We got 96 yellow marbles, yellow, 72 pink. Okay, each bag should contain the same number of marbles. Okay, so each bag is going to have the same number of marbles. So if one bag has 5, every bag has 5. And all of the marbles in a bag should be the same color. So if this bag is full of marbles and they're all yellow, they all should be yellow. None of them should be pink. So this is a problem where they don't mix the marbles. So again, and in this bag, you should have the same number. So in here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There's 11 here. There should be 11 here. 3, 6, 7, 8, 9, 10, 11. And this is all pink. If one is pink, then all of them should be pink. Okay, so the conditions are definitely different here. Same number of marbles in each bag, and we're not mixing colors. A bag will be unicolor, if you want to call it. Okay, it will only contain marbles of a single color. So let's go. So, and the word greatest shows up, so it's definitely a GCF problem, but just a little bit different. So let's start. 96, 72, blah, blah, blah. Let's pick 2. 2 would be 48, 36. 2 again. Actually, I'm going to use 12 because I can. Okay, I can even go up that high. 12 goes to 48 4 times. 12 goes to 36 3 times. Being that this is a GCF problem, the GCF is the product of those two, which is 2 times 12 gives you 24. Now, you got to be careful here. So I'm going to do this, and I'm telling you right now, the wrong way first. So some of you, and a lot of you, will probably do this, or probably did this. So you got 24 over there, and you said, okay, I'm going to make 24 groups. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 17, 18, 19, 20, 21, 22, all right, whatever, 23, 24. There's your 24 groups, and in this group, I'm going to put 4. Let me call this yellow, and this is pink. 4 yellow, 3 pink, 4 yellow, 3 pink, 4 yellow, 3 pink. Okay, now, if you did this, what's wrong with it? Well, the question said, first of all, you can't mix the colors. So all these bags, okay, have yellow and pink inside. Yellow and pink, yellow and pink, yellow and pink, yellow and pink. So that already tells you that this is definitely not the way to go. Okay? Because it said they should all be of the same color. Yes, they have the same number in each bag, but it should be of the same color. So that's not going to work. So here is what your answer is going to look like. So this is actually the number of bags for each color. So the yellow, okay, and here's your yellow. You're going to have 4 groups. 1, 2, 3, 4. Your pink is going to have 3 groups. 1, 2, 3. The GCF in this particular question stands for the number of marbles that go in each. 24, 24, 24, 24, and even here, 24. All bags must have the same number. Is that correct? Yes, it is. Do all bags have one marble of, one color? Only one. What do I want to say? One bag has yellow. One bag has a yellow marble. All the other marbles in that bag should be yellow. So it's unique colors in each bag. That's what I'm trying to say. So this bag only has yellow marbles. This bag has only yellow. This one has only yellow. This one has only yellow. This one has only pink, and only pink. There are no mix-ups here. Okay, so this is your answer. Okay, so in this case, the GCF stands for the number of marbles in the bag of each color. 24 pinks, 24 pinks, 24 pinks, and yellows on the other ones. Okay, you got to be careful. Please revisit this question. Okay, number 10, 24 sixth graders and 40 seventh graders. Okay, Mr. Cho wants to divide them into groups of equal sizes, so we want to break the 24 into groups. Kids here and the kids here. We'll break them up into groups. Okay, each group will only have students of the same grade, so we're not mixing the 24 sixth graders with the 40 sixth graders. So this group here will only have 6th graders. I don't know how many groups we're breaking them into yet. And the 40 that we're going to break into groups, they will only have 7. We're not 7th graders inside each group. Okay, the only thing we know for sure is that if the number is 3 here, guess what? Every bag will have 3, even here on the 7th grade side. Okay, so let's see what it is. It's definitely GCF. Okay, that we know for sure. Instead of 2, let's go higher. Let's go 4. 4 into 24 is 6. 4 into 40, 10. We could have gone higher. 2 works, 3 and 5. So GCF, and 24 stands for 6th grade. Write that down, label your numbers on top. It makes life so much easier. GCF is definitely 8. GCF is 4 times 2, which is 8. Now, again, I will do this the incorrect way. So if you did this and you said, okay, there's 8 groups. 1, 2, 3, 4, 5, 6, 7, 8. And I'm going to put 3 6th graders and 5 7th graders, 3 5th graders and 6th graders, and 5 7th graders, 3, 6, 5, 7, etc., etc. in all of them. It doesn't meet the criteria. Okay, it does meet that they have 8 students in each bag, but they are not 8 students. Of the same grade. So that is not going to work. So again, if it question, hopefully you're getting that. If it's a question that says we're not going to mix the items, the students, then it's definitely a GCF problem where these numbers here actually dictate the number of groups. So for the 6th graders, which we had 24, okay, we're going to break the 24 6th grader into how many groups? Yes, it is 3. 47th graders, we're going to break them into what? Into 5 groups. And the GCF, which was 8, dictates the number of people we're going to put in each. 8, 8, 8, 8, 8, 8, 8, 8. They all have the same number, and in each group, you'll only find people of that same grade. Okay, so the final answer, so the answer here, how many students should be in each group? 8 students. Please write it out. 8 students should be in each group. Okay, I'm going to go back to the prior questions because I did not answer the question. The prior question says, how many bags will have pink marbles? The answer to this question is 3 bags will have pink marbles. Okay, right here. 1, 2, 3. Okay, last two. 8, 7, 3, 4, 5 dividido por 56. 56 goes into 8. No, it doesn't. Does it go into 87 one time? 56. Oh boy. 56. Subtract 31. Bring down the 3. I'd say it goes about 5 times. 6 is 30. Goes 3. 28 to 80. Subtract 3. Oops. Borrow 2. 1. 3. How do I know it went 5 times? Because I did this already twice already. 4. It goes 5 times again. 6 would have been a little bit too much. So 280. Subtract again. 4. Borrow 2. 13. 540. I don't know why I have problems with 5. So 5 comes down. Comes down. 56. 560 would have been 10 times. So it's definitely 9. And 6 times 9, I have no idea. 9 times 6 is 54. Carry the 5. 45, 50. Good. And you have 41 over here left over. Final answer. 1,559 remainder 4, or if you wrote it as a fraction, which you can simplify to 2 over 32. No, you can actually simplify it to 1 over 16. Sorry. 1 over 16. Okay. So, how to take in this. Okay. One more. 1, 2, 3, 3, 5 divided by 23. What am I doing? Sorry. Wrong day. No, I was in the city. So, actually went to Hunter College, for those of you who were wondering where I was today. We had it's called a professional development for teachers day. Yeah. So, 23 goes in 21, 23, I don't know, 5 times. 5, 23 is 15, goes 1, 10, carry. Let's subtract this. Borrow, 13 minus 5 is 8. Bring the 3 down about 4 times. No, too much. 3. 9, 3 times 2 is 6. Subtract, borrow, 7, 13, 4. 7 minus 6 is 1. Bring down the 5. 7? No, 6 should be fine. 6 times 3 is 18. Carry the 1. 6 times 2 is 12 plus 1, 13. La impresta del 1 al 5 se queda como 15. 15 menos 8 es 7. Ok, la respuesta sería 536 con un remainder de 7 o 536, 7 sobre 23. Okay, that's it. Questions? If you want me to do a problem again, or I will do it, I don't have any issues, just email me, let me know. Okay, oh, I forgot. Oh, I told you. So, hopefully you watched this, and if you did watch, I'll make it worth your time. 2 points on your, 2 free points on your test when you write these 3 words on the top of your test sheet. Let's write this down. Okay, I'm not going to actually say it, but so remember these 3 words. And don't tell anyone, okay? You watched the video, you suffered through these 20 minutes, you should get credit. Okay, so if you actually watched it, remember these 3 words, and you write it on your test on Monday, you get 2 points. Okay, again, if you have any questions, please write. Okay, just hit the contact button on the website, and I'll reply back or even do another video with that particular question. Okay, that's it.